So this is our example problem for the two related samples t-test. So does a litter program reduce litter? So would we actually have less trash after instituting this program? So we looked at 4 cities. We looked at before the program was introduced. So this was before 7-4. We introduced the program in August of 2004, and then we took a measure of litter in July of 2005, so a year later. What we then do is we're going to look at each group, and we're going to create a difference score. Remember, that's the main difference between the dependent means t-test and the single sample t-test. It's just that we're going to need to calculate those difference scores. So again, you can see that this is a within subjects design. We have Fresno is participating in both categories, in both conditions. Merced is participating in both conditions. Bakersfield is participating in both conditions. And Stockton is participating in both conditions. These are all cities in California that are participating at 2 times. So what we're going to do is calculate those difference scores. So 9 minus 2 is 7, 10 minus 4 is 6, 8 minus 9 is 1, 9 minus 1 is 8. Again, we'll look and see what those difference scores are. We'll add them all together, divide by 4, we get a mean difference of 5. So now these new values, 7, 6, -1, and 8, are going to be the values that we're going to use from here on out. We're no longer going to use that raw data. We're only going to use the difference scores. So again, population 1 is the cities that participate in the program, and populations 2 are cities that have no change in litter amounts. Our research hypothesis is that cities in the program will have more litter reduction than in population 2. So we'll have more reduction in the litter participation than in cities that don't. So our null hypothesis is that program made no difference in litter. There was no decrease in the amount of litter. So we're going to say that these two things are equal. And again, we are talking about litter reduction. So are we talking about a one-tailed or two-tailed test? It's a one-tailed test because reduction indicates a directional hypothesis. So that's again why you're going to see that directional research hypothesis. But again, you can always do things as a two-tailed test, as a more conservative estimate as well. So our comparison distribution is a distribution of means again, and it's a t-distribution. And because remember, t's are a family of distributions, you have to tell us which t-distribution we're dealing with. Here we have 4 different participants, 4 different participant cities. So we have 4 minus 1 is equal to 3. Again, we're going to assume that our population mean is 0 because we're always comparing against no difference. Because again, no difference is our null hypothesis, and this is null hypothesis testing. And again, the variance is unknown, and we must estimate that. To estimate that, we'll take our difference scores and we'll perform sums squared on those different scores. Notice we're no longer dealing with our raw data. We're exclusively dealing with our difference scores. And that's again why this now becomes essentially like a single samples t-test, because now we're just dealing with one group, which is essentially the difference scores. So we'll take each of the scores, subtract the mean of 5 from them, square each of those values, and add them together. And so again, we have our sums of squared for difference scores is 50. We'll take that into our equation and estimate the variance based on that. So 50 with a degrees of freedom of 3. 50 divided by 3 is 16.67. 16.67 is the estimation of variance for our population. It's again what we're going to use in our t-test. What we're going to use in our t-test then is going to take that value and make it into the estimated standard error for different scores. So what we'll do is we'll take that value, divide it by the number, 16.67 divided by 4, we get 2.04. And we take the square root of that to get 2.04. Again, we're dealing with a one-tailed test, so we're going to determine the cutoff. It's one-tailed high because we're again talking about that reduction. We'll use the t-table if in this example we're using an alpha level of 0.01 with our degrees of freedom 3. Our cutoff is 4.541. And here's, again, the t-table that you would look that up in. We're looking at one-tailed tests, so we'll only look under that column. We're looking at 0.01%, so we're only going to look under that column. And we're looking at degrees of freedom 3. So you can see how we got to 4.541. We're going to want to find that t-statistic. So we're going to take our mean difference score, subtract the estimated our value for the population, which again is 0 because we're always comparing against the idea of no difference. And then we're going to put that estimated standard mean difference scores at the bottom for our denominator. Again, the top is going to be our signal, the bottom is our noise. So we have 5 minus 0 divided by 2.04, which is equal to 2.45. The sample is not in the critical region. Again, our cutoff value was 4.51. So we were not able to that was not in the cutoff region, so we failed to reject the null, and our results are inconclusive. So we could say a one-tailed t-test was inconclusive, and we would still give that t-statistic. We would still tell us what's t-distribution. Instead of saying the 0.05, however, or the 0.01, we say not significant. Or you could say is greater than 0.01. You could say that instead of less than, which is again which our next one is gives that p is greater than 0.01 instead of p is less than 0.01. Either one of those are completely appropriate. So again, you can see that these are really simple. They're very familiar to those of you who are comfortable with the single sample t-test. And after doing the independent samples t-test, this seems like a cakewalk, hopefully. So please, again, get comfortable with this. Look at the video from Dr. Good if you're still having problems with how to calculate them. He's got some sample problems. You can either do the problem and then look at his videos. There's 2 there, and there's a practice problem that I give as well. Again, do the problem and then go look at the answers. We'll continue to do some examples on Wednesday, and we'll add in some more pieces of the equation in terms of effect size and the like. I hope that makes sense. I'll see you guys Wednesday.